Welcome to another incredible edition of Comet Algebra. This video is for Algebra 1, Chapter 8, Section 3, Scientific Notation. So let's start with a brief review of what scientific notation is, and your science teachers will love it that you know how to work with this. So first of the first part. This first part of the number is always in between 1 and 10. In other words, there's just one digit in front of the decimal, like 1.7 up to 9.9. And then this does refer to a time sign in scientific notation. And since we have a base 10 number system, this is 10 to a certain power. And this power tells you how big or how small this number really is. If it's a positive exponent, then the number gets bigger by moving the decimal point to the right. So if you were to write, I don't want to write this out in standard notation. So this would be, but I will, 4.8, we'd have to move the decimal over 10 times. In other words, you've got to add 9 zeros. So let's see, 1, 2, 3, 4, 5, 6, 8, 9. So it's right there. So yeah, I don't even know what number this is. 1, 2, 3, 2, 3. Okay, 48 billion. All right, nice big number. You heard me say standard notation. When we talk about that, it's just writing the number the regular way we always have. To review here, this next part, if you have a negative exponent, this number is getting incredibly small. And to make it small, we move the decimal to the left. So I'd have to take this 7.243 and move the decimal 6 places to the left. 1, 2, 3, 4, 5, 6. And put in the 5 zeros that I need. Okay, so hopefully you remember that, because now we're going to take these numbers in scientific notation and work with them with adding, subtracting, multiplying, and dividing. And the reason that we're looking at scientific notation now in the exponents chapter is because when you multiply and divide with numbers in scientific notation, you have to follow the rules of exponents. So when you better write this down if it's not in your notes. When you multiply in scientific notation, you actually go ahead and multiply the numbers. The numbers part are like the 7.5 and the 2. So you actually do multiply those. And then to get the correct exponent on your 10, you add the exponents. So let's try this out with our first example. So we have to take 7.5 and multiply it by 2. When I did that, I got 15 times 10, and now I need to figure out this exponent. So I have a negative 5, and I'm going to add to that a positive 7. So I get 10 to the second power. Now, this is correct. However, it's not in correct scientific notation. So we have to remember this first number can only have one digit in front of the decimal point. Right now it has 2. So I need to take this decimal point and move it so it's in between the 1 and the 5. If we adjusted the decimal point, then we certainly need to adjust this exponent. And the way I like to tell you is if you're making this number smaller, because we went from 15 to 1.5, if this number is getting smaller, then your exponent has to get bigger so that you can maintain the accuracy of your number. So since we made this number smaller by 1, we need to increase this exponent by 1. And so now it becomes 10 to the third. This is incorrect scientific notation. This first one was right when we had 15 times 10 squared, 10 to the second, which if I write it in standard form is 1500. And then if I write this one in standard form and move the decimal over 3 places is also 1500. So these two turn out to be the same in standard form, but only this one is in correct scientific notation. So just to review, you multiply the numbers and you add the exponents. So now when we're dividing in scientific notation, we would divide the numbers and of course subtract the exponents. All right, in this next example, I saw that I had a typo, so I fixed it. Now we're going to do 2.4 times 10 to the 7th divided by 6 times 10 squared. So remember, we go ahead and we divide the numbers. And 2.4 divided by 6 is 0.4. And then we got to figure out our exponent here, times 10 to what? Again, we subtract the exponents because we're dividing. 7 minus 2 is 5. This is the correct answer to the division, but it is not in proper scientific notation because we don't have a number in front of the decimal. The 0 doesn't count. So we need to move the decimal one place over, and we're making the 0.4 to the number 4. So we made this bigger. And if we made this number bigger, we have to make the exponent smaller. So in scientific notation, the correct answer is 4 times 10 to the 4th. Now, adding and subtracting in scientific notation is very different than what we just did with multiply and divide. When you are adding and subtracting in scientific notation, you have to stop and look at the two numbers you're trying to add or subtract, and you can't even do it unless the decimal points line up. Because you remember when you learned how to add 4.2 and you were going to add 0.38, you didn't write it like this and try to add it. Okay, you learned that if this is 4.2, you have to line up the decimal points like this. Well, we have to do that in scientific notation, and in order to have the decimal points lined up, you ready for this? The exponents must be the same. So you can't even do an add-subtract problem unless you stop, make the adjustment, make the two exponents exactly the same by doing this adjustment process, and then go ahead and add them. So this is kind of what I was saying in the previous examples, but I didn't put it into words. So this is very handy to have in your notes. When you're making these adjustments, if you're making the number go up, you're making it bigger, the exponent has to come down. And vice versa, if you're making the number smaller, making the number go down, then you have to raise your exponent. Okay, very important. Please know this. And you're just going to have to remember this for your science classes because you will be dealing with numbers in scientific notation. So let's look at an example. We see that we're subtracting these. So the first thing we do is check our exponents. This has an exponent of 15 and this is 14, so you can't add or subtract them, so you just need to stop. Think about what adjustment you want to make. Now, what's difficult for me as a teacher is that there's two different ways to proceed. You could adjust this number so that you had an exponent of 14, and then you could leave this one alone. Or you could change the second number to have an exponent of 15, and then they both would. So there is no wrong way. You can do it either way, and then you just adjust your answer as needed in the end so that you do have both numbers in correct, or I should say your answer in correct scientific notation. So I guess since I started writing this first one to the 14th power, I'm going to leave this second one alone, and I'm going to change this one. So you'll notice it was 10 to the 15th, now it's 10 to the 14th. This exponent came down, therefore I have to make my number bigger. So 5.4 becomes 54. And now I can go ahead and I can subtract the number part of these scientific notation numbers, and my answer is going to have the decimal point at the 10 to the 14th power. Notice we didn't do anything with the exponents. We didn't add them, subtract them, multiply, divide them. We did nothing. All we did is line up the decimal points. And now you can go ahead and add 54. I'm sorry, subtract 54 minus 4.7. I got 49.3. So now this is the right answer, it's just not in correct form yet. So we need to adjust, moving the decimal point over so that I have one digit in front. This becomes 4.93. I went from 49 to 4.9, so I made this number smaller. Therefore, I have to make my exponent bigger by 1. And now my answer is correct, and it is in correct scientific notation. So now you have the information you need to do section 8.3. So have fun with math.